So in this case, we are going to continue as part of our derivatives. It's a section that you are supposed to know as you are going to consider the sketching of graphs later on. You are going to be considering sketching of graphs, which is actually working with the cubic graph to be precise. So the factor theorem, here's a part where it's going to play a part on that sketching of the cubic function, where you are to determine the roots of the cubic function. A cubic function is the one that we write in the form ax cubed plus bx squared plus cx plus d. So let's say we are given this as y is equal to that. That's a cubic function, and you need the roots, just like a quadratic function. There was a condition where you are going to determine the roots of the function, where we consider y to be equal to 0 in the x-axis. So the same thing for a quadratic function, you are going to notice that where x is equal to 0, in the x-axis, where y is equal to 0, there are three possible values of x that you must have, which are the roots. And those roots are from whatever cubic function that you're given. Let's say you are given a cubic function, then you let y to be equal to 0. You have something like this: x cubed minus x squared minus 5x minus 3 is equal to 0, which is an equation that you must solve to obtain the values of x for whatever that you're going to be having. So that part now of solving these equations of this nature is where our factor theorem plays a role. And this factor theorem allows us to factorize. And after factorizing, you can solve an equation. Let's say I've got x minus 1 into x plus 2 into x minus 5 is equal to 0. This is in a factorized format. You can find the values of x from this, because you just have to equate each bracket to what? To 0. So that is where we are to use our factor theorem now. The factorization of such expressions, when it is not an equation, an expression like this, how can you factorize this? In order for you to factorize this from our factor theorem, we have got two ways. There are actually three: the algebraic way, and the long division, and the synthetic division. So in our class, we are going to consider the factor theorem in application with the long division. Then we are going to have another class in application with the synthetic division. All right. So like I said, we need these roots, which are easily found from factorization of a cubic function. So to factorize a cubic function now, it follows that the factor theorem, let's discuss this separately. The factor theorem, it is actually factor and remainder. So we are not going to have a condition of a remainder. We want to consider where it is a factor. If you are given f of x as a function, given f of x, that's your function f of x. From that function of f of x, if you substitute a value from that f of x, let's say f of x is equal to ax cubed plus bx squared plus cx plus d, like this. Then you substitute a value, let's say f of 1, f of 2, f of 3, whatever that you're given. In place of x, you substitute a value. Then it happens that you substitute a value and you obtain a 0, like this. F of 1, it gives you a 0. Once this happens, that a certain value that you substitute and you obtain a 0 from that, it then follows that x minus that value that you substituted is a factor, of f of x. X minus the value that you substituted. So if I substituted a 1 and obtained a 0, therefore x minus the value that I substituted minus 1 is a factor. So that's our factor theorem. You obtain a factor from the value that you substituted, and you obtain what? And you obtain a 0. All right? So that is the condition. So we can say if here f of k is equal to 0, therefore x minus k is a factor of what? Is a factor of f of x. That's a most important thing that you must consider. Meaning to say, if f of -3 is going to give us a 0, let's say you substitute the value of x, then you obtain a 0. Therefore, our factor was supposed to be x minus k, the value that you substituted, which is -3. So meaning to say we are talking about what? X plus what? X plus 3 minus, that's what? That's a positive. So x plus 3 is a what? Is a factor. That's the whole idea there. The value that you substitute. So k is a constant. So the long division now is applied or is used to find the remaining factors. All right? Or the synthetic, whatever that you're going to use, any other method, guys, any other method. In our case, we are going to focus with what? Long division. So that's the long division. The long division is used to determine the remaining factors. To determine the remaining factors. The remaining factors. That is the condition. So as a cubic function, you must have 3 factors, 3 brackets, this into this into 3 brackets. For a normal consideration, yes, sometimes they can be 2. I'm going to see what will happen, but that's the condition now. The long division is used to determine the remaining factors. So how now do I have, how can I obtain the value of what? The value of k. All right, let's consider this as our example. Let's say we want to factorize. In this case, let us start by what? Factorization. Factorize. Factorize. All right, so in our case, we want to factorize x cubed minus x squared, all right, minus 5x minus 3. This is what we want to factorize. So in order for us to factorize, I say that you must have a factor from the value that you're going to substitute in order for you to obtain a 0. Then use the long division now to determine the remaining factors. So we must substitute values of x, any, to see which one is going to give us a 0. Like, let's say 1, f of 1, you substitute f of... So those are the factors. So these factors, you're not going to try anyhow, guys. You're not just going to use any value, 2, 3, 4, 5. No. You try from the factors of the constant, which is -3 or just 3 as it is. With the factors of 3, those are the numbers that you are going to try of the constant. So you work with the factors of what? Of the constant. So when it is a 3, whether it's a -3, it's a +3, you look at the factors of 3, plus or -1. It's a factor of 3. 2 is not a factor. If you divide by 2, you're going to get a remainder. 3 is a factor, plus or -3. Those are the only numbers that you're going to try. These are factors of what? Factors of 3. You do not just try any number plus or -5, then you substitute. For each factor, you use it as plus or minus. So this is what I'm trying to say. When x is 1, 1 is a factor of 3, the constant. So let's try f of 1 and see what you're going to have. In place of x, you substitute what? 1 in place of x. So that's 1 squared minus 5 times 1 minus 3. So let me just use this one and just have our calculator here. So that's 1 to the exponent of 3 minus open bracket 1 squared, all right, minus 5 open bracket, put -1 minus 3 like this. So this one is going to give us a 2, not a 0. We need a 0 there. So meaning to say 1 is not going to work. This is totally out. We move on. Plus or minus, we move on to the negative, f of -1. You do the same thing, substitute -1. So here I'm just going to do it on the calculator, wherever there is. Sorry guys, here I did put a -1 instead of a 1. Yeah, sorry for that. So it was supposed to be -8. Still, -8 is not part of our answer. So sorry for that. Here I just made a mistake. It was +1. All right. So this time we are going to put a -1. All right, a -1 here, a -1 here, a -1 here. So this is going to give us a 0. So as we can see, guys, when you substitute -1, you are obtaining a 0. So instead of trying 3, -3, this and that, use the first value that you're obtaining that is giving you a 0, this one, because we're saying if f of k is equal to 0, therefore x minus k is a factor. So in our case, therefore x minus our k, this is f of k, which gave us a 0, which is what? -1, which is what? X plus 1 minus minus is going to give us what? A plus. Is a factor, this one. Is a what? A factor of our f of x, this part here. It is a factor for this. So with the factor x plus 1, you use the long division. So long division is another part on its own. So you can check other classes where I did this part of long division. Even if you check mathematics N3, mathematics N4, for the sake of revision, but I'm going to explain it so that we can understand each other. So we have got the first factor, this one. This is our first factor, which we obtained by using this idea to say any number that is going to give us a 0 from that f of x. From that, you obtain a factor from x minus k, x minus that number, x minus -1, x plus 1. So now let us apply our long division. So be very careful. How am I going to apply this long division? You're going to use it later on. For those who want to use long division, there's another way, which is the synthetic division. I'm going to have another class separate to that. So long division, you take your expression, the one that you're given. So that's divide by what? X plus 1. This is your factor, x plus 1. So it's going to be x plus 1 into that function, x cubed minus x squared minus 5x minus 3. So that's an application of your long division. So you must divide. How are you going to divide? Please take note. On your division, you are going to be working with the first term of your expression, this one, the first term to the first term of what? Of your factor. So it is x cubed divided by x. What are you going to have? So you divide first. Divide x cubed divided by what? Divided by x. So this is going to give us x squared. So you write it on top. So that's x squared. So you divide. Always first term versus first term. First term versus first term. Always first term versus first term for whatever that you're given. This to the first term. So that's x cubed divided by x. Then after that, so you divide. After division, you multiply this back to the expression, to the factor as it is. So take note on the multiplication there. You multiply back as it is, guys, everything here into x plus 1. This x squared multiplies everything. All right. So it's going to be x squared into x plus 1 like this. X squared multiplies everything here. So x squared times x is going to give us x cubed. So you write it under here, x cubed. All right. X squared multiplies 1. So x squared times 1, that's what? X squared. So you write it under, this is x cubed. So you write it under here, x squared. These powers are supposed to be following each other. X cubed, x squared, x like that. So you divide, multiply back, then you subtract. All right, you subtract. So that is the idea. You subtract. So this is up to this 10. This one is just like a zero there. So just subtract this part. All right, so you subtract. Let us subtract x cubed minus x cubed. That's a 0. Meaning to say there is nothing there. Minus x squared minus x squared minus x squared minus x. Those are like terms. So minus 1, that's minus 2x squared. So this is going to give us minus 2x squared. You have subtracted, then you drop the remaining terms. So you drop the remaining terms. What is remaining here? Minus 5x. You drop it down, minus 5x. What is remaining here? Negative 3. You drop it down like that. Then you repeat these steps again and again until you obtain a 0. So you're going to repeat. What are we repeating? We are now having a new expression. Remember, this was our original, this one that we started with. Now we are at this stage. So we are back now to the division. And I said our division is always what? First term to the first term. This is our first term for this part. So we are going to divide first term to the first term. All right. So meaning to say, this is what you're going to have. Divide. We're going to have first term to the first term. Minus 2x squared to the first term here, which is what? Which is x. So this one and this one are going to cancel and you remain with 1x. So that's minus 2x. Only one is going to remain. There are two of them. So minus 2x is what you're going to have. You write it on top. Minus 2x. Whatever that you're obtaining here, when you multiply, remember, you must multiply everything. So minus 2x multiplies everything here, just like before. So it's minus 2x into x plus 1. It multiplies everything. Minus 2x times x. That is what? Minus 2x squared. You write it down here, just like here. Minus 2x times minus 1. That is minus 2x. So you multiply the bracket, writing it down. Then after that, you must what? Subtract. So here we are going to subtract. So this is what you're going to have at the end if we subtract. All right, let us subtract. Minus 2x squared minus, take note, minus 2x squared, you subtract minus 2x squared, so it's going to be a positive. So minus 2 plus 2, that's a 0. So this one is going to give us a 0. Minus 5 minus 2. Take note there. Minus 5x minus, what are we subtracting? We are subtracting 2x, minus 2x. So it is going to give us a positive here. So minus 5x plus 2x, that's negative 3x. So this is going to give us negative 3x. We are done with our subtraction. So what is going to happen with the negative 3? We drop the remaining terms down. So we're going to drop that negative 3. All right. After that, we are supposed to repeat. What are we repeating? That division that we had there, which states that always it is the first term versus the first term to that x, that always to that x that you are having here, you divide. So in our case, we are going back to that division, our first term minus 3x over what? Over our first term there, which is what? Which is x. So this is going to give us a negative 3. So that is what you're going to write here on top, negative 3. Then that negative 3 multiplies back everything now. Negative 3 into x plus 1. That's negative 3 times x, negative 3x. Negative 3 times 1, negative 3. It multiplies everything. After that, we subtract. So as we can see, guys, we are subtracting the same thing. Minus 3x and minus 3x, that's a 0. Minus 3 and minus 3, that's it. We are subtracting the same thing. So that is going to give us what? A 0. So you repeat until you obtain a 0. If you are not obtaining a 0, guys, it means x plus 1 is not a factor. Let's say you do this, guys, and you obtain a 5 here, a 7. It means what you are saying is a factor is not a factor, or you made a mistake on your what? On your division here. This is your long division. This is how you apply long division. So remember, with the application here, we are to factorize, remember. We factorized and obtained the first factor, x plus 1. And I said that long division is therefore used to determine the remaining factors. Which are these factors that we are talking about? It follows that it is just like this, guys. It's just like 6 over 2 is equal to 3. 2 is a factor, 3 is a factor of 6. So the product of these factors gives us a 6. 2 times 3. So in our case, this part that we're having, it is the same as our 6, what is dividing. So it follows that x cubed minus x squared minus 5x minus 3 is equal to, just like 6. 6 is equal to what? 2 times 3. What we use to divide, which is what? Our factor x plus 1. And what we obtained after dividing, just like 6 divided by 2, you get a 3. So what we obtained after dividing is what? Is x squared minus 2x minus 3. From this whole idea, 2 times 3 gives us a 6. So it means the product of these two factors are supposed to give us the original function that we are given before. So that is what you have here. Can we factorize the second bracket? If possible, factorize, because you must factorize what? Fully. And that's a quadratic. Remember, a quadratic, guys, it's easier to factorize. So when it is like this, you know that already you have got what? X plus 1. And here, let us see if this can be factorized. Do we have factors of 3, which gives us negative 2? Factors of negative 3, yes, negative 2 and 1. If you add, you're going to get a negative 2. So thus, we can factorize this. Since the coefficient of x squared is 1, this is going to be x, this is going to be x. Then those terms here from the factors, negative 3 and what? Negative 3 and 1. So we have factorized this fully. This is a positive 1, is that so? Yes, that's a positive 1. And this was this a positive? Let's go back. Let's go back. This is x plus 1, yes. So meaning to say we have got two brackets that are the same here, x plus 1 and x plus 1. We can even write it as what? X plus 1 squared into x minus 3, like this. You can even just write it that way. All right, since we've got two brackets that are exactly the same. So this is the factorization. This is your factorization from the long division. So the long division, it is used now to determine the remaining factors. This part of the quadratic, which you can factorize, that's the remaining factors. The first part, you just substitute your values. All right, that's the first part. You just substitute your value into this original expression that you're given. The one that is going to give you a zero, let's say 1 is giving us a zero. You use that one. If 2 is giving, you use that one. But do not just try any numbers. You use what? Factors of the constant. Factors of the constant. So if it was a 3, you have to try f of 3, substitute in place of x. F of minus 3, you do that. So it's still from whatever quadratic that you're going to have, we might not have the exact part, but at the end, these brackets that we are having here at the end, guys, sorry for that, very sorry. These ones at the end, they are supposed to be exactly the same if you have done your factorization properly. These brackets at the end must be exactly the same. So you ought to do your factorization properly. That's the most important thing. To do the factorization properly from this consideration of our long division. So now that you've got factors, you're going to notice, like I say, it's an application. This one, it's an application that you're going to have later on, like I was saying, from this cubic function concept. They will ask you to solve this because it is a cubic function and you want to determine the x-intercepts, where y is equal to 0, then you equate this to 0. So you use that long division now to find those factors. Then after finding factors like what we have, x plus 1 into, it was x minus 3 into x plus 1, you now equate to 0. These are now the roots to the given function, the x-intercepts. These are now the x-intercepts, where each bracket you have to equate to 0 when x plus 1 is equal to 0, or x minus 3 is equal to 0, or the bracket of x plus 1 is equal to 0. So meaning to say x is equal to what? -1, or x is equal to +3, or x is equal to a -1. So those will be the x-intercepts on our applications now. But as for now, this part of the factor theorem is the one that I want you to understand. We are going to sketch the graphs later on. Here, this part. A value substituted into the original function to give us a 0 will give us a factor. If we introduce a negative like this, x minus k, it becomes a factor of that function. And long division is therefore used to determine the remaining factors. There is another method which is called the synthetic division. Just like long division used to determine the remaining factors, it is also used to determine the remaining factors. But in our case, we were focusing on the what? On the long division. So I want you to use the same idea that I have applied on this question of the long division to answer any question. Try to use this to answer any questions that you must. That is the idea, guys. All right. So try this one again. Remember, this was to factorize. So I want you to try this to factorize minus x cubed minus x squared plus x plus 10. So you consider the factors first. So if you are to do this, you're going to notice that your answer was going to be x minus 2 into, all right, even the negative, you can take it out here. So if you take, or just like minus x squared minus 3x minus 5 is the same, or you take the negative out, so it's gonna be x minus 2 into x squared plus 3x plus 5, which cannot be factorized further. This is what you're going to get, or this one. So I want you to try this question to factorize this and see if you're going to obtain this answer. So for you not to have a lot of things guys, I told you that you try factors of what the constant, which is 10, factors of 10 plus or minus 1, plus or minus 2, 3, 4, 5, 6, 7, 8, 9, 10. These are factors of 10. You try these ones. You substitute 1 and see if you're going to get a 0. The one that is going to give you a 0, you use that one to determine the first factor, like what we obtained, where f of minus 1 is equal to 0. Therefore, the factor is what? X plus 1. So here I just gave you a hint. So use that. Try using long division, all right? Try to find the remaining factors. This is what you're going to get as your final answers, any one of these two. So if you're not obtaining this, let's communicate. That's why the comment section or the community section is also there so that we can communicate. So if you do not understand, let us consider that. But our next class, we are going to focus on the synthetic division. So that is it. Till we meet again.